Zoom in on grid reference C4. That irregularity exceeds tolerance.
I see it. Reworking the parameters now.
A robotic arm precisely positions a thermal imaging camera above the high-performance aramid fiber prepreg sheet.
Automated software assigns a quality grade to the high-performance sheets. The primary radar transfer. The robotic applicator meticulously positions the edge of the second composite ply, ensuring a precisely engineered. The laser projection confirms the geometric integrity.
Perfect adhesion across the surface.
Vacuum integrity holding steady at 28 inches.
Confirmed. Ready for the autoclave sequence.
Slight waver on the vacuum trend line.
Adjusting the bleed valve now. It's stabilizing. We are good.
Getting 25 degrees on the lower curve.
Mine matches. The core temperature should be ready. We have separation at the apex. Force reading stable.
Confirmed. Proceed with extraction.
After sanding, the 4.5-meter Su-34 Radome is subjected to an high. As the robotic sprayer applies the light gray, off-white radar transparent coating, a non-contact laser sensor can.
After the first coating layer is applied, the 4.5-meter Su-34 Radome is gently heated by
signal attenuation holding steady below the threshold.
Radar cross-section is nominal. Looks like a successful run, optimizing process A.
The transparent resin flows rapidly through the fiber network, visible through small observation windows.
The high-strength composite wingtip fairing undergoes automated edge trimming. A high-speed diamond cutter precisely removes flash material.
The rack moves into a temperature-controlled curing area where specialized UV lamps rapidly cure the
Accelerometers measure the resonance response, ensuring the component does not exhibit detrimental harmonic vibration modes, confirming structural stability.
The laser scanner captures millions of data points, comparing them to the CAD model. As the deviation map shows, the component is perfect.
The completed, dark gray high-strength composite wingtip fairings move on to an automated packaging line, where
All right, bring it back easy. Watch the ramp. And stop. Stop. Okay, let's move out. Secure a little.
The technician ensures perfect alignment of the 1.2-meter composite fairing during Process B, highlighting the precision machine.
Su-34 checklist, step 9 or 2, composite shaping confirmed.
Verified. Ready for operational flight duties.
The Su-34 undergoes a high G turn, demonstrating the resilience of the composite wingtip fairing under extreme operational conditions. The Su-34 flies at high subsonic speed over rugged terrain, demonstrating routine operational usage. The high-strength composite wing.
This final shot emphasizes the critical and reliable contribution of these secondary structural components to the aircraft's overall readiness.